Hello, I'm John Andrew Kane Hovellana, and in this video, we will solve questions related to axial stress. This is under Day 3 or General Engineering of the Chemical Engineering Board exam, specifically under Strength of Materials. For our problem, we're given a lantern that weighs 9 pound-force, hangs from the ceiling using a steel cable with a diameter of 0.05 inches. The steel cable has a failure yield strength of 60 KSI. The factor of safety for the design is set at 1.5. Question number 4, what is the stress in PSI on the cable? Question number 5, what is the allowable stress in KSI? And question number 6, what is the maximum allowable force in pound-force that the steel cable can support without exceeding the allowable stress? So for the first question, we need to calculate the stress in PSI on the cable. And we can consider that the lantern, let's consider this box as our lantern, is hanging from this ceiling using a steel cable. So let's assume that the steel cable is cylindrical or it has a circular cross-section. The stress, specifically the axial stress, can be calculated as sigma is equal to force over cross-sectional area on which the force is acting. So we can have force F as 9 pound-force divided by the cross-sectional area of this steel cable. The area of the circle can be given as pi over 4 d squared. So our cross-sectional area is pi over 4 d squared, where the diameter is in inches, 0.05 inch. Quantity squared. So we will have a unit of pound-force per square inch, and this is equivalent to PSI. So 9 pound-force divided by pi over 4 divided by 0.05 inches squared, we can have 4583.662361 PSI. So from the choices, this is letters 4584 PSI. For question number 5, what is the allowable stress in KSI? Recall that KSI is equal to 1000 PSI. So we are given failure yield strength of 60 KSI, and we are also given a factor of safety of 1.5. Typically, we should use the materials below its failure yield strength by accounting the factor of safety. So we can somehow write that the allowable stress is equal to the failure yield strength divided by the factor of safety. Substituting the values, this is equal to 60 KSI divided by 1.5. So calculating 60 over 1.5, we have 40 KSI. So from the choices, this is letter A. For our last question, we will use this allowable stress to solve question number 6. What is the maximum allowable force in pound-force that the steel cable can support without exceeding the allowable stress that we have calculated as 40 KSI. So from the previous equation, we have calculated that the stress is equal to force over cross-sectional area. Now that we have the allowable stress and we still have this dimension of the cable, we can determine the maximum allowable force as F equals sigma A. So sigma, the allowable stress, is 40 KSI, or this is 40,000 PSI. Recall that PSI is equivalent to pound-force per square inch. And the cross-sectional area, A, of this steel cable is given by pi over 4 d squared, where the diameter is 0.05 inches squared. So calculating 40,000 PSI times pi over 4 times 0.05 inches squared, we can have the maximum allowable force as around 78.5398 pound-force. From the choices, this is equivalent to letter A, 78.5 pound-force. And that's it for our problem on axial stress. So if you enjoyed this video, please like and subscribe. See you on our next video.